Hey everyone, my name is Maggie Carlson and today I'm going to be teaching a lesson on proteolysis. So basically proteolysis is the breakdown of the dietary proteins into single amino acids or into small peptides, and the peptides from there are then further broken down through catalyzation into single amino acids. Protein is used in our body and is metabolized a lot, but our body only uses a certain portion of the energy of protein for energy. Proteolysis is used to break proteins down for digestion and into a single amino acid so that it can go through the cycle to be used for energy. First step of proteolysis is oxidative deamination. Oxidative deamination is the removal of the nitrogen amine from the amino acid. As a result, you get the byproduct of ammonia and a keto acid, which is also known as a carbon skeleton. So the next step in proteolysis is the actual extraction of energy from the amino acid. So you can see we have gone from our amino acid, we removed the nitrate amine, and we ended up with a keto acid or the carbon skeleton, and that is the only way that it can enter the TSA cycle is as a carbon skeleton. So your glucogenic amino acids are going to follow, which are these acids right here, are going to follow this path and turn and convert into a pyruvate, which then can be synthesized into acetyl coenzyme A. From there, it can enter into the TSA cycle. The second way that can happen are ketogenic amino acids, where you go from your amino acid to your carbon skeleton, and these two ketogenic amino acids can go straight into the acetyl coenzyme A, which can then be transferred into the TSA cycle. So amino acids can enter the TSA cycle, like I said, at different points. I gave 2 examples of different ways that they can enter the TSA cycle, but the way that it is determined how they enter the TSA cycle is by how much ATP it has produced. So the amount of ATP produced will determine the starting point. So the higher the ATP, the higher starting point you have going into the ATP cycle. No amino acid will create as much ATP though as the glucose does. The excess protein that comes when you eat and then it is metabolized into energy is then either used, and when it's not used, it's stored and synthesized into a fatty acid and is stored as the triglyceride. Ammonium is the other byproduct that I mentioned that comes out of the oxidation part of proteolysis, and that has to be transferred or made into urea, or it can be toxic to the body. Thank you. I hope y'all enjoy.